Hi, I'm Dennis Prevost, and I'm here representing Irrigation Solutions. Now, Irrigation Solutions has one motto, and that's to get your water running the right way. Now, what Irrigation Solutions does is they design irrigation systems for residential housing, commercial buildings, larger scale like golf courses or farms, and even as small as gardens or greenhouses. Now, Irrigation Solutions' latest design is an electric water detection system that conserves water. This system detects even the slightest bit of moisture while controlling your irrigation system. Now, a little bit on project planning here. The project decision here was made first. We came up with project ideas and made a project decision, and then based on that decision we came up with some system ideas, how the system was going to work here. Under that, the system ideas, we came up with some system parts and a system overview and kind of how the system would flow. Now, based on that, we came up with system details, and under system details we were able to design our controller, do circuit design and board design. Once we were able to design all of those different components, we came up with some part specs, as you can see here, and once we came up with being able to spec some parts, we came up with a bill of materials. Finally, we were able to complete the system and do a basic simulation of the system, and finally we hit a milestone of the completion of the project. Some major system components. Obviously we have a switch which powers the controller and the entire system. Also, we have a moisture sensor, major system component that will detect if there's any water present. A solid state relay, which is used to provide enough power for the solenoid actuated valve, which controls the flow of the water to the sprinkler head. Now, kind of idea of how the system actually works. It's all powered by a 9-volt battery. The moisture sensor is also powered by that battery, as well as the switch and the controller. The controller takes an input from the moisture sensor, and depending on if there's moisture present, that controller will output to a relay, which will control the solenoid actuated valve and will control the flow of water to the sprinkler head. Now, if everything goes as planned, you should have water to your sprinkler head. Now, going into some system details, we have this moisture sensor up here, which is always tied high to the 9 volts DC, one side of that, and then the other side is tied to a 2-input AND gate, as you see here in our integrated circuit. Now, the other side of this AND gate is tied high to that 9 volts as well, right here. This moisture sensor sensitivity is determined by this resistor network here, and will determine how sensitive your moisture sensor will actually be. On the output side of your integrated circuit, on your AND gate there, you see the solid state relay. Now, what this does, this provides enough power with this 24-volt DC supply to your solenoid valve to control your water. Now, this solenoid valve here is a one-way, 2-position solenoid actuated valve. that will, it'll only work in two positions. Either the water is flowing or the water is not. A kind of overall flow of the system and kind of how the controller works. You turn the controller on and off with that toggle switch, as you saw previously. The controller goes into a sprinkler off state. So from the sprinkler off state, it goes into the moisture present state, where if there is moisture present, it'll continue to have this sprinkler off. But if there's no moisture present, as you see here, it'll go on to a sprinkler on state. Once that sprinkler comes on, it'll go back to this moisture present state. If there's still no moisture present, back to sprinkler on. If there's moisture present, it'll make its way back to sprinkler off. Also to note, at any time here, you can see these dotted lines represent the path back to home, so to speak, I would call it. And basically saying that any time in any state here, the system can be powered down in case of emergency, for safety reasons, for maintenance, whatever the case might be. Now a basic kind of a basic system simulation. As I said in the previous slides there, the moisture sensor was kind of up and to the left as the sponge is. Now the sponge actually represents that moisture sensor, whereas if this would be tied high to 9 volts here. This would be the other input to the AND gate, and this LED here would represent the the solenoid actuated valve. In this case here, if the sponge was wet, you would conduct here, which would make this input also high, make the AND gate output, and output to your solenoid actuated valve, or in this case your LED. Now taking a look at the last 2 rows of this chart here, this is a binary representation of the computation that actually happens within this integrated circuit, this AND gate. So here is your always tied high, your 9 volts, which is this upper input of the AND gate, 1A, and also the other input, 1B. Now in the case where there's nothing being conducted through the sponge because the sponge is dry, this other input is a 0, which makes your output a 0. Now in the case where there's moisture present, like we talked about just barely, that would simulate a 1. So this would be tied high to 9 volts, as well as this be tied high to 9 volts, which a 1 and a 1 in this binary computation would give you a high output, which would then make your LED illuminate. Now this kind of overall design was designed to keep your water running in the right direction while sustaining the planet. The overall idea of this project was to conserve water. Now that's what Irrigation Solutions does. It keeps your water running in the right direction while sustaining the planet. And on behalf of Irrigation Solutions, I'd like to now take any questions, please.